Find the equation of the line passing through the points 3, 1 and negative 1, 5. Write the equation in point-slope form, slope-intercept form, and standard form. So we're given 2 points on this line, so the first thing we're going to do is find the slope of the line. We do have a formula for calculating slope using 2 points on the line, and that's m equals y2 minus y1 over x2 minus x1. So we'll label one of our points as x1, y1, label the other point as x2, y2, and substitute into the formula. The y2 is 5, minus y1 is 1, over x2, negative 1, minus x1, 3. We have 5 minus 1 in the numerator, that's 4, and negative 1 minus 3 in the denominator, that's negative 4. 4 divided by negative 4 is negative 1. That gives us our slope. Once we have the slope, we can start writing the equation in these different formats. We're going to start with point-slope form. Point-slope form is y minus y1 equals m times x minus x1. The reason why I started with this format is because it requires us to have a point and a slope. So we have the point x1, y1, and now we have the slope, and we'll be able to write this format. So we have our same x1, y1 that we used, and the slope that we just calculated. So that's y minus y1, that's 1, equals negative 1 times x minus x1, which is 3. So we have y minus 1 equals negative x minus 3. This is our point-slope form. So then we want to write it in slope-intercept form. Slope-intercept form is y equals mx plus b. So with slope-intercept form, we want to write the equation that we just found. So we're going to take the equation that we just found and write it so that we have y equals all the x terms combined, all the constant terms combined. So we start with that point-slope form that we had, y minus 1 equals negative x minus 3. We want to get rid of the parentheses with the distributive property. That gives y minus 1 equals negative x plus 3. And I'm going to add 1 to both sides. We get y equals negative x plus 4. So this is our slope-intercept form. And then finally, we want to write it in standard form. Standard form is when you have your x and your y term on the same side. So that's ax plus by equals c. So standard form is when you have your x and y term on the same side, your constant on the other side. So we can start with our slope-intercept form, y equals negative x plus 4, and we want to move the x and the y terms to the same side. So we're going to add x, that's x plus y equals 4. So we have x plus y equals 4, the x and y terms on the same side and the constant on the other side. Now the one comment is this example didn't have any fractions in it. In my math lab, standard form also has a and b and c being integers, so no fractions. If you do have fractions, you would clear the fractions out, multiplying by a common denominator on every term. So there we have our point-slope form, our slope-intercept form and our standard form. On this example, we have an exponential equation, 5 to the x equals 2. We want to solve this exponential equation for our variable in the exponent, x. And there are 3 methods that we typically use to solve exponential equations. We try to make the bases the same, which we can't do in this example. We take the log of both sides. Or we can convert it to a log. So I've already mentioned that we can't make the bases the same. We can do either one of these methods. Let's do both of them. So if we take the log of both sides, you can use any log you want, but I typically use natural log because it's usually on the home screen of your calculator. Natural log on the left, natural log on the right gives us natural log of 5 to the x equals natural log of 2. And once we introduce the logs, then you can use your power rule for logarithms. You can move that exponent as the coefficient. That will give us x natural log of 5 equals natural log of 2. And then we're going to get x by itself by dividing both sides by natural log of 5. So we have x equals natural log of 2 over natural log of 5. So that's doing it with the method of taking the log of both sides. If we have 5 to the x equals 2 and we want to solve by converting to a log, the reason why we can convert it to a log is because log and exponents are inverse operations of each other. So we're going to write this as log base 5. So the base of the log and the base of the exponent are the same. And because they're inverses of each other, the input of the exponential is the output of the logarithm, and the output of the exponential is the input of the logarithm. So rewriting it as a log would give us log base 5 of 2 equals x. So even though these answers look a little bit different, they're equivalent to each other. They're the same decimal approximation. Log base 5 of 2 is the same thing as natural log of 2 over natural log of 5. A graph of a function is shown to the right, actually below. Using the graph, find the following function values. That is, given the inputs, find the outputs. So we have f of -8, f of 0, f of -4. -8, 0, and -4 are the inputs or the x's. We want to find the outputs or the y's. So our inputs are the x's, our outputs are the y's. So if we want to find f of -8, we know that x is equal to -8. So here's where x is -8 on the scale. And if I draw a vertical line at x equals -8, this vertical line is all ordered pairs that have an x of -8. We're specifically looking for the ordered pair that's on the line. So it's going to have an x of -8, and some y-coordinate. Let's see what that y-coordinate is. That y-coordinate is 5. So we have the ordered pair negative 8, 5 that's on the line. So that means that our output for this is 5. We'll do the same thing with the next one, f of 0. The input is 0, x is 0. So if I find 0, 0 is at the origin where the x-axis and the y-axis cross each other. So if I draw this vertical line here, that vertical line are all ordered pairs where x is equal to 0. We're going to look for the one that crosses the line. It has an x of 0 and a y of, looks like, negative 5. So our output is negative 5. F of 0 is negative 5. And then we have f of negative 4. So here's negative 4 on the scale. If I draw a vertical line there, I kind of made it messy, so let's clean it up. If I draw a vertical line there, these are all ordered pairs. That vertical line represents all of the ordered pairs where x is equal to negative 4. We want the one where it crosses the line. And I know it's kind of hard to see on my y scale over here, but that is right at the origin. That y coordinate is 0. So we get the ordered pair negative 4, 0, and f of negative 4 equals 0. We want to solve the exponential equation 7 times 10 minus 6 to the 2x minus 3 equals 9. So we have this exponential equation, and the first thing that we need to do is isolate our exponential. So we've got the variable in the exponent here, and that expression in the exponent is attached to this 6. So that's what I mean by the exponential. We want to isolate that 6 to the 2x minus 3 on one side before we can do our methods for exponential. So to isolate that exponential, I'm going to have to get rid of these parentheses. I'm going to divide by 7 to get rid of the parentheses, and I have 10 minus 6 to the 2x minus 3 equals 9/7. I'm still working to isolate that 6 to the 2x minus 3, so I'm going to subtract 10 on both sides. On the left, I'm left with negative 6 to the 2x minus 3, and on the right, I need to clean this up. 9/7 minus 10. I want to combine those together, and to combine them together, I need to have a common denominator. So 10 is the same thing as 10 over 1. So we have a denominator of 7 and a denominator of 1. The common denominator is 7. So I don't need to change the first fraction. It's 9 over 7. The second one, I'm going to multiply by 7 over 7. And that's negative 70 over 7. And now that I have a common denominator, I'm able to combine those fractions together. We keep the denominator of 7 and we do the math on the numerator. 9 minus 70 will give us a negative 61. So we have negative 61 over 7 on the right-hand side. Okay, I still am working towards isolating that exponential. So now I want to get rid of this negative. Divide both sides by -1. That gives 6 to the 2x minus 3 equals a positive 61 over 7. So now that I have that exponential isolated, I'm able to use my methods for exponential equations. I have 3 typical methods, making the bases the same, and I can't do that in this example. Or I can take the log of both sides, or I can convert it to a log. I'm going to take the natural log of both sides. So I do the natural log on the left. I get natural log of 6 to the 2x minus 3 equals natural log of 61 over 7. Now that I've done the natural log on both sides, I can use the power rule for logarithms and move that exponent to the coefficient. That gives 2x minus 3 times natural log of 6 equals natural log of 61 over 7. So now I've got that variable out of the exponent. So once the variable is out of the exponent, I'm using my algebra skills to solve for x. I've only got one x, so I need to isolate that x. But before I isolate that x, let's get rid of the parentheses. Because that x is in the parentheses, I want to get rid of the parentheses. We've got 2x natural log of 6 minus 3 natural log of 6 equals natural log of 61 over 7. And now the parentheses are gone. I'm still working to isolate that x. So I'm going to add 3 natural log of 6 on both sides. And that gives 2x natural log of 6 equals natural log of 61 over 7 plus 3 natural log of 6. I'm still working to isolate the x. I'm going to divide by 2 natural log of 6. And I get x equals natural log of 61 over 7 plus 3 natural log of 6 over 2 natural log of 6. So we've got our solution here, but most of the problems require you to enter this in your calculator and get a decimal approximation. So let's practice with our calculators as well. So my calculator's loading. And the most common thing that I find students having trouble with on entering in their calculator is the parentheses. So one of the reasons why the parentheses are so confusing for this is that the calculator automatically will put an open parenthesis next to all of these natural logs. So you're going to have an open parenthesis for the natural log. So you have to remember to close the parenthesis at the end of that natural log. So you have to do it around here and around here and around here. But you also have to remember that this fraction bar acts as a grouping symbol that we don't have to write when we're writing it down like this, but in our calculator we do have to write it down. because your calculator is not using the fraction bar, it's using a division symbol. So it has to know that you're dividing all of this by all of this. So there are a lot of parentheses for grouping in here. So let me just tell you. So you're going to have an open and a close for every single one of these logs. And you're going to have an open and a close for the numerator and an open and a close for the denominator, so that your calculator knows exactly what goes in each log and what goes in the numerator and what goes in the denominator. So let's type this in. It's going to be parenthesis, natural log of 61 over 7, close parenthesis, plus 3 natural log of 6, close parenthesis for the log, close parenthesis for the denominator. We'll do our division, parenthesis for the denominator. We have 2 natural log of 6, close parenthesis for the log, close parenthesis for the denominator. And that gives us 2.104. Let's say we round to 3 decimal places, but pay attention to the directions in your problem. The directions will tell you what to round to. It might say round to 3 decimal places, or it might say round to the hundredths or thousandths place. And so you'll have to pay attention to what to round to based on those directions. So we have, let's say, 2.104 for this one. A baseball player swings and hits a pop fly straight up in the air to the catcher. The height of the baseball in meters t seconds after it's hit is given by the quadratic function h of t equals negative 4.9 t squared plus 9.8 t plus 1. How long does it take for the baseball to reach its maximum height? And what is the maximum height obtained by the baseball? So we're given that this h of t equals negative 4.9 t squared plus 9.8 t plus 1 will tell us the height of the ball. So this is going to tell us the height, and the t stands for time. So if we substitute in some time t and work out this formula, it's going to tell me the height at that time. That's what this formula does. Now our goal in this question is to find the maximum height. We want to find the maximum height. And that keyword maximum in this problem is your keyword that tells you how to solve this problem. So when we're looking for the maximum, that's going to be our highest. And we're given this quadratic function. So we want the highest part of the quadratic. So we have this quadratic. We have a being negative 4.9 A is the leading coefficient, the coefficient on the squared term. And the reason why I'm calling that out is because when you know the coefficient, you know a sketch of the quadratic. So because our A is negative, less than 0, we know that we have a parabola that looks like this. And remember, we want to find the highest or the maximum. In that picture, the highest is going to be right here at the vertex. So when you see these things together, you're asked for the maximum, you're given a quadratic. That means that you're going to use the vertex to answer the question. So you're looking for those keywords in the problem, and that helps you to know what to do. So we want to find the vertex of this. We have a formula for finding the vertex formula, and this might be a little bit confusing. We typically label the vertex as HK. So the reason why that's confusing is because we have an H here as well. So this H is for the height, and this H is the x-coordinate of our vertex. So we have a formula for that, H, and that is negative b over 2a. So this H right here is not the height. This is just the x-coordinate of our vertex. So this is, actually, it's not even the x, because we're not using x in our equation, it's the t. So this stands for time. So b is 9.8, and we already said that a is 4.9, so we get negative 9.8 over 2 times negative 4.9, and we're going to put that in our calculator, negative 9.8, and I think 2 times 4.9 is 9.8. That's right, so we have negative 9.8 over negative 9.8, and that's 1. So now we know that we're going to reach the maximum height when the time is 1. And now we can figure out the height, which is going to be our y part of the vertex. So we're going to plug in that time of 1 into our formula. We get negative 4.9 times 1 squared plus 9.8 times 1 plus 1. So this works out to be negative 4.9 plus 9.8 plus 1. That's 4.9 plus 1, which is 5.9. And let me just see the units on this problem. It is meters. It says that up here. So we are going to have a max height of 5.9 meters at t equals 1 second. So we've got 2 questions here. How long does it take for the ball to reach the maximum height? The how long is 1 second. What is the maximum height? That's 5.9 meters. The price P and the quantity X sold of a small flat-screen television set obeys the demand equation. How much should be charged for the television set if there are 80 television sets in stock? What quantity X will maximize the revenue? What is the maximum revenue? What price should be charged in order to maximize the revenue? We have P equals negative 0.19x plus 323. So this right here, this P equals negative 0.19x plus 323, this is called the demand equation. That lowercase p stands for price, and that x is the quantity. How many of our flat screen television sets? So the demand equation is going to tell us that relationship between the price and the quantity that we sell. So in this part A, it says how much should be charged for the television set if there are 80 television sets in stock. How much should be charged is referring to the price. If there are 80 television sets is referring to the quantity X. So in this first part, we're going to use the demand equation that's given to find the price that should be charged. So we'll substitute in an 80 into that demand equation. We have negative 0.19 times 80 plus 323. Let's put that in our calculator. Move it over here so I can see. We have negative 0.19 times 80 plus 323. And that gives us our price of $307.80. So, if there are 80 television sets in stock, we're going to set a price of $307.80. Now, for part B, let's read it again. What quantity X will maximize the revenue? What is the maximum revenue? So we have our keyword here of maximize, maximum, and this is our clue to what type of problem we're going to be dealing with. We're going to have a quadratic where we're going to be using the vertex to solve the problem. But we have a little bit of work before we get to that part where we do the vertex, because we want to maximize the revenue, and we were not given the revenue in the problem. So we have to put in a little work first to get that revenue. Now there is a formula for revenue, a business formula. Revenue equals X times P. That's the same X and P that we were using earlier. P is the price, X is the quantity, and that capital R stands for revenue. So if we take our P here and we substitute it in for the P, we will have revenue equals X times negative 0.19x plus 323. I can use the distributive property, and that's negative 0.19x squared plus 323x. So now we have the revenue, and you'll notice that the revenue is a quadratic because of the squared. So it's a quadratic with a equal to negative 0.19. A quadratic with a negative leading coefficient is going to be facing down, and the max will be at the vertex. We have a formula for finding the vertex. The vertex is going to be an ordered pair, hk, and our formula for h is negative b over 2a. We already know that a is negative 0.19, and b is this 323. So we have negative 323 over 2 times negative 0.19. Let's put that in our calculator. We have negative 323 over negative 2, should be 2 times negative 0.19, and we get 850. So what does that 850 stand for? That variable in our equation is x, and that x stands for the quantity. So we're saying that in order to have the maximum revenue, we need to have 850 television sets. So then we're going to find the k. We find the k by substituting into our revenue function. That's negative 0.19 times 850 squared plus 323 times 850. We'll put that in the calculator as well. That will be negative 0.19 times 850 squared plus 323 times 850. And that's 137,275. So we're going to have a maximum revenue of $337,275 by selling 850 television sets. So that's the two parts we have in part B here. The two questions. What quantity will maximize the revenue? 850 television sets. And the maximum revenue is 137,275. Now we have one more question to go, one more part. What price? Price is that lowercase p. What price should be charged in order to maximize revenue? So remember, our price is based on quantity. X is quantity. So we have 850 as the quantity to maximize. So I'm going to substitute that 850 into the demand equation to figure out what price we're going to set. So we have negative 0.19 times 850 plus 323, and that's $161.50. We've addressed all the parts here. We've got a maximum revenue of $137,275, selling 850 television sets, and we're setting a price for those television sets at $161.50. Use the vertical line test to determine whether the graph represents a function. So I took a screenshot from our notes on how to use the vertical line test. We want to draw vertical lines on the graph, and we want to count the number of intersection points. If there's more than one intersection point on any vertical line, the graph is not a function. If every vertical line has one or no intersection points, then the graph is a function. So the particular graph that we have here is a vertical line. So if we're doing the vertical line test, all the vertical lines that we draw away from the vertical line have no intersection points. So all of these have no intersection points. But if we were to draw a vertical line on top of our vertical line, this is going to have infinite intersection points. Every single point on this line is an intersection point. So we have infinite intersection points. So this means that we do not have a function. So just read this part again. If there is more than one, it is not a function. We have infinite, which is more than one, and that's not a function. So if you think about these ordered pairs, all of these ordered pairs are 2 comma something. So all of these ordered pairs have the same x with different y's. With the definition of a function, every x has to have exactly one y. Here we have an x with multiple y's, and that is not a function. So this graph is not a function. Together, teammates Pedro and Ricky got 2,673 base hits last season. Pedro had 281 more hits than Ricky. How many hits did each player have? So this is an example where we can set up a couple equations from the information. And when we have those equations, we have a system of equations. And we'll solve that system with substitution or elimination. So we're going to say, if we read the question again, it says, how many hits did each player have? So let's set up some variables. I'm going to let P stand for how many hits Pedro had. And let's let R be the hits for Ricky. Because that's what we want to answer. We want to answer how many hits Pedro had and how many hits Ricky had. And when we read this first sentence, it says, together, Pedro and Ricky got 2,673 base hits. So the word together is what indicates that if we add Pedro and Ricky's hits, we'll get 2,673. So one of our equations is the number of hits for Pedro plus the number of hits for Ricky will be 2,673. Then in the second sentence, we've got Pedro had 281 more hits than Ricky. So Pedro had 281 more than Ricky. And so we get this equation P equals R plus 281. Pedro has 281 more than is add to Ricky. So that gives us two equations with two unknowns, and we're going to be able to solve this. You can solve this with substitution or elimination, but since the second equation has P equals, I'm going to use the substitution method. We're going to substitute this into the other equation. That gives R plus 281 plus R equals 2,673. Combining the r's together, we get 2r plus 281 equals 2,673. We're going to subtract 281, and that gives 2r equals, let's see, 2,392, and I'll divide 2 into that to get r equals 1,196. And so this is the number of hits that Ricky had, 1,196. Then we can substitute that back into one of our equations to see that Pedro had 281 more hits. So 1,196 plus 281 would give, let's see, I do better when my equations are stacked up. $1,487. So Pedro has 1,487 hits, and Ricky has 1,196 hits. Thank you for checking out my videos. Have a great day.